Hello and welcome to 2-3. Today we're going to be talking about translating between tables and expressions. So we're going to write expressions for tables and sequences. I couldn't find a really good picture to depict this, so I thought I would just give you an inspirational math quote. It says, "Even the hardest puzzles have a solution." So you need to keep that in mind, and instead of telling yourself it's impossible, just search through your toolbox and try a different tool. See if that's the right one to solve the problem. All right, here we go. So we need to write an expression for the missing value in the table. So when I'm looking here, I'm seeing to go from 9 to 11, I'm adding 2. To go from 10 to 12, I'm adding 2. To go from 11 to 13, I'm adding 2. 12 to 14 again, adding 2. Now, it is in your best interest to go through and make sure every single one of those cells, every single one, it follows the same pattern. Because you could get a plus 2, plus 2, plus 2, and a plus 3. And then you would have a different pattern. So we've got to make sure we don't just see 2 plus 2s and say, oh, well, the rest might follow that pattern. We need to actually sit there and figure it out. Okay? So to go from n, my expression would be n plus 2. N plus 2. So that would be my expression for this table. Let's try another one. So same direction, write an expression for the missing value. Now, I could do minus 11, but I don't think that's what our expression or our pattern is going to be. I think this one looks like a divide by 12 type of pattern. Is 24 divided by 12 2? Yes. Is 36 divided by 12 3? Yes. Is 48 divided by 12 4? Yes. So our expression is going to be E divided by 12. Now, could I write 12 divided by E? No, I could not, because the order matters when we're doing a division problem. So this would be the expression that I would use for this table. All right, another expression we have to write. Okay, position 1 is 3. Position 2 is 5. So I'm saying a lot of times we try to find going this way. But in this case, we are going this way. Okay, in when a 1, out came a 3. In when a 2, out came a 5. In when a 3, out came a 7. In when a 4, out came a 9. In when a 5, out came an 11. So here I'm saying I'm adding 6, adding 5, adding 4, adding 3, adding 2. But how do I write that in an expression? Let's see if we can think of something else. Could I multiply by 2 and then add 1? Let's see. 1 times 2 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. Oh, I think we got it. 3 times 2 is 6, plus 1 is 7. 4 times 2 is 8, plus 1 is 9. 5 times 2 is 10, plus 1 is 11. So you're going to be tempted to say, well, how do I even do this? It goes from 3 to 5 to 7 to 9. Nope, we're not thinking that way. We are going up and down. If in goes a 2, out's coming a 5. In going a 3, out coming a 7. Okay, so my expression for this one is going to be n divided by 2 plus 1. Okay, n divided by 2 plus 1. All right, now that one was a little bit trickier, and it might take you a little bit longer to come up with that. So the more we practice, the easier your brain will be able to figure out those patterns and come up with your solution. All right, lastly here, a triangle has a base of 8 inches. There's our 8 inches. The table shows the area of the triangle for different heights. Write an expression that can be used to find the area of the triangle when its height is h inches. Okay, so I'm doing 8 times, how's this going to go? Luckily, I know the formula for an area of a triangle, and I know that that is area of a triangle equals 1/2 the base times the height. Okay, so if I look at this, I know 8 times 1 is 8, and then I'm going to divide by 2 to get my answer. Multiply the base and the height and divide by 2 to get my answer. So, because I know that, I can figure this out, but we need to be really careful that we're looking for those patterns. So if I say my expression here will be 8h, I'm multiplying 8 and the h, and then I need to divide the whole thing by 2. Okay, you could also write it as 8h divided by 2. That would be fine too, because we would multiply before we divided, because we work from left to right. So that would be okay too. So anyways, that's all that I have for you today. We're just kind of looking at tables and trying to make expressions, find expressions that work for each table. So anyways, thank you very much, and I hope you have a great day. We'll see you tomorrow.